Hey everyone, welcome to topic revision videos of the CIE A Level Mathematics. Today we're going to talk about the first chapter from the Pure Maths 1 syllabus, which is quadratics. In quadratics, the first skill that we must master and look at is completing the square. Now, we have studied this profusely in O levels and IGCSE, so the concept is not unfamiliar to us. However, I will walk you through different ways we can do that, and we'll do some practice examples also. So, there are two kinds of uh, cases that you will see. One case is case 1, you will have an expression in the form x squared plus bx plus c, which you will need converted in y is equal to x minus, I'm going to use different letters over here just to differentiate between b and c over here. And case 2 would be if you have non-unitary coefficient for x squared. So for example, ax squared plus bx plus c. And we will need it converted into ax minus p whole squared plus q. Let's look at through the algebra of this, and then I'll show you the examples for them also. So case 1, let's see the case 1 first. So let's look at how this will look like with simple algebra. So first off, what we will do is we will put the brackets between x squared plus bx and c. We know how the squares work. So if you have x plus y whole squared, it will look like x squared plus 2xy plus y squared. And if it's x minus y whole squared, the only thing that will change is your minus sign in the middle. So if you have a plus sign in the middle term, that means it's a square of a sum. And the middle term is 2xy. So your bx is actually 2x and the third term. So just disregard the x over here. So your third term, let's call it y for us. No, not y. Let's use some other variable. Let's use m over here. So the third term would be m equals to b by 2. So your expanded square will look like x squared plus bx plus, since we are writing the expanded square, plus b over 2 squared and minus b over 2 squared. Why? Because we need to keep it as x squared plus bx. If we don't write the minus part, it will change the expression itself. Now, further, we know that only this is part of the square. We can write this thing outside. So this would become x plus b over 2 whole squared minus b squared over 4 plus c. So this is just one example of how this could look like. And when you do the sum of this, you can have a plus in the middle. This is the constant and this will be the square. Case in point, let's do an example over here. Let's say you have x squared minus 4x plus 7. And this is, let's say, y equals to that. So we would do the same thing. First off, we would put brackets surrounding the x squared minus 4x because that's the square we want to complete. Now, focusing on the x squared minus 4x, if we want to finish the square, or complete the square, the middle term divided by 2, so 2 squared minus 2 squared. So this will turn into x squared, x squared minus 4x plus 2 squared minus 2 squared plus 7. And then what we will do, this is the square and the middle term means that this is the square of a difference. So x minus 2 whole squared minus 4 plus 7. This simplifies to x minus 2 whole squared. 7 minus 4 is 3. Simple, straightforward. You can see this from over here that we could have found the constant term from this also, but that would be a very long process. But just to show you that this actually is the same thing. So C was originally 7, right? And B was 4, right? Or actually minus 4, whichever way you want to stick with it. So when you have minus b squared over 4 plus c, you have minus b squared is 16 over 4, and c was 7. So minus 4 plus 7, that is 3, and that is exactly what we end up with. And b over 2 is this third is the other summand, that is the 2 over here. And since the b was itself negative, minus b, so you got minus 2 instead. But that was just for concept. You don't actually have to do it this way. You can just straightforward do it this way. But you have to understand the process behind that. Now, case number 2. Case number 2, where you have a x squared plus bx plus c turned into y equals to p x minus q whole squared plus r. Process is simple, straightforward. Again, we have to do the same thing. First off, we isolate these by putting the brackets on them. And then we take a out. We factorize a out. So this will become x squared plus b over a x plus c. Process after that is straightforward, same as before. This is the square we need to complete. So let's use a different color. So x squared plus b over a x. Now b over a is the middle term, so the third term would be b over 2a whole squared minus b over 2a whole squared and plus c. So this becomes the completed square. This will become the the third term, b over 2a whole square. But when we take this term out now, we have to remember that there is an a will be multiplied with this term. So b squared over 4a squared times by a, so b squared over 4a squared times by a will cancel out one of the a's. So this would be b squared over 4a plus c. Now, you can make it this way however you like. So let's take an example. Let's take an example. Let's say you have f of x equals to 2x squared minus 12x plus 7. So, and we need to convert it into ax minus b whole squared plus c. F of x equals to. So we would do the same thing as before. We would bracket these two terms. Then we will take 2 out, making it into x squared minus 6x plus 7. Then we know that this is the expression for which we need to complete the square. So this will become x squared minus 6x. 6 divided by 2 is 3, so plus 3 squared minus 3 squared plus 7. And this will become 2. This is the square x minus 3 whole squared minus 2 times by 3 squared plus 7. This will become 2x minus 3 whole squared minus 2 times by 9 is 18 plus 7, simplifying to 2x minus 3 whole squared and minus 18 plus 7, that is minus 11. So this would be the form that we are looking for. Now you can check whether this value conforms to this expression that we had. So let's just quickly check that. Okay, well, that's fine. So b was 12, actually minus 12. So b squared would be minus 144 divided by 4 times by 2. 4 times by 2 plus 7. C was 7 over here. So let's calculate. So minus 144 divided by 8 plus 7. As you can see, minus 11. So exactly what we had over here. Right. Okay. So now let's look at some recent questions to practice this concept, and let's look at some different scenarios also. So let's look at this question. By expressing minus 2x squared plus 8x plus 11 in the form where a, b, and c are positive integers, find the coordinates of the vertex of the graph with the equation this. All right, so before we do this question, just a little tidbit, which we are going to discuss in the graphs topic also, that when you have this expression, quadratic expression in the completed square form, b comma c would be the turning point. This is fairly common knowledge. We have already seen this in O levels also. Find out the turning point or the vertex of the graph. So basically, to find out the vertex of the graph, we need to find out b and c. That means we need to rearrange that or re-express that in completed square form. So we would start by same thing, by taking the minus 2 out this time. So minus 2x minus 4x plus 11. So notice the signs over here. We can we have to compensate this with an extra minus sign to make it into plus 4x, plus 8x. Now let's take this as y. We need to complete the square for this one, so minus 2 remains out, so x squared minus 4x. 4 divided by 2 is 2, so plus 2 squared minus 2 squared plus 11. Now, the first three terms, we can combine this in the form of x minus 2 whole squared. But remember, this minus 2 has to multiply with this minus 4 also. So this minus 2 times by minus 4 plus 11. So this would become minus 2 x minus 2 whole squared. This would become plus 8 plus 11, and that would be minus 2x minus 2 whole squared plus 19. And that's about it. Now we need to find out the vertex. So vertex of the graph would be this value would be 2 comma 90. And that's about it. Let's see another question like this. Let's see this one. The function f is defined by f of x 3 plus 6x minus 2x squared for x belonging to the real number set. That means all values in the real number set. Express f of x in the form where a, b, c are constants and state the range of f. Right. So the range will be decided by the vertex. We are already familiar that when the coefficient of x squared is negative, the graph is like this. So just like the previous question that we saw over here, the vertex is actually a maximum point. So the range would be below this value. So all we have to do is to find out the maximum point, the C, or actually the A over here, that will dictate that. Now we start by just simply gently rearranging this by keeping the x squared term front. And then we repeat the process by taking minus 2 outside. This would become x squared minus 3x plus 3. So finally, this would become minus 2 x squared minus 3x. And we already know what to do now. Plus 3 by 2 squared minus 3 by 2 squared plus 3. So these are the terms of the square. So this would become minus 2x minus 3 by 2 squared minus 2 times by minus 9 over 4 and plus 3. So this would simplify to minus 2x minus 3 over 2 squared. 2 cancels out with 2, minus becomes plus. So minus, minus 9 over 2, plus 9 over 2. 9 over 2 we already know to be 4.5. 4.5 plus 3 is 7.5, 15 over 2. And finally, that means this is the maximum point. So the x-coordinate of this point is minus 3 by 2 and 15 over 2. So the range would be f of x is less than equal to 15 over 2. Although we will cover these concepts more again in the functions topic, this is fairly easy concept over here. All right, so since we're obviously this is not the only time we will be discussing this, let's move on to the next concept in this topic, which is the discriminant. Discriminant tells us whether the quadratic equation that we have will have real solutions, and if real, how many, and if not real, what would be the case. So basically, the discriminant, we don't actually have to do all the derivation over here. The discriminant, we already are familiar from the O levels and IGCSE that this is the discriminant. B squared minus 4ac is the discriminant. And the value, specifically the sign, whether it's greater than 0, less than 0, equal to 0, that will decide whether the quadratic equation has solutions or not. And we can actually see that in many different ways. So if it is greater than 0, if it's greater than equal to 0, you will have real solutions. More specifically, if it is greater than 0, you will have two distinct real solutions. And if it is equal to 0, you will have one solution. That will come off as a duplicate scenario. That means it will still be a square, but it will have an identical solution. So you will still have two, but they will be identical. And if b squared minus 4ac is less than 0, you will have no real solutions for the equation. No real means these solutions will be complex in nature, and we will see this in P3 what this means. Now, there are other ways to check whether a quadratic equation has a real solution or not. And the easiest thing to is we have already seen this completed square form. So when we have a quadratic function, when we have a quadratic function, ax squared plus bx plus c equal to 0, if a is positive, you will have a U-shaped graph, and if you have negative value, you will have this type of graph. So if it has two roots, two distinct roots, it will be looking like this, right? So two distinct roots. So if it has two roots, the completed square form, ax minus b whole squared plus c, c will be negative. C will be negative in this case if a greater than 0. And if we reverse this scenario, if a is less than 0, c would be greater than 0. See, the vertex would be greater than 0. Similarly, if we modify this for one single root, if we modify this for a single root, when you have a single root, the c coordinate or the c thing would be 0. That means this would be a form of a perfect square. So one root would mean this is just like this. And whether or not you have a less than form or greater than form, c would be equal to 0. You can identify this from the completed square form also. But if you do not have no solutions, if you do not have any roots, how this will look like? It will look like the graphs are floating. So this is for a greater than 0, this is for a less than 0. So in this case, if a is greater than 0, c would be greater than 0 also. And if a is less than 0, that means an inverted U shape, c would be less than 0 also. So this is another way of checking whether you have real solutions possible or not, other than discriminant. Note that we will get questions paired with the functions topic and the coordinate geometry topic also. So this topic will be revisited. We will often have to work with the inequalities and the equation type to work with that. Now, moving on to solving quadratic equations and inequalities. So first, let's focus on equations. In O levels and IGCSE, we solved quadratic equations by factorizing the quadratic equations, which is still fine. The roots would be x equals to b, x equals to c. And we also have ax squared plus bx plus c form, for which I will come back in a second. There are two further ways to find out the roots. Now, one is quadratic equation, which is the x is equal to minus b plus minus b squared minus 4ac, and as you can notice, b squared minus 4ac, this is the discriminant. That's why it is the discriminant, because if this factor is less than 0, there will be no square root. And another way to solve quadratic equations is completing the square. So both of these ways, quadratic equation and completing the square, can be used to solve quadratic equations. This method may or may not work all the time. It depends on the ability of that quadratic equation to be factorized that easily. So it may or may not work all the time, but quadratic equation and completing the square will always work. Now, let's see the same questions that we were talking about and try to solve these quadratic with equation and completing the square. So we had this thing, x squared minus 4x plus 7. So example, y equals to x squared minus 4x plus 7. First, let's see quadratic formula. Quadratic formula is short, but you have to be very careful with the numbers. So you have x is equal to minus b plus minus b squared minus 4ac whole under root divided by 2a. So b is already minus 4, so this would be 4 plus minus b squared 16 plus minus 4 times by 7, 28. Oh, sorry, no. Minus 4 times by 28. 4 times by 7, I meant. Over 2a. Now, as you can notice, the b squared minus 4ac is coming out to be negative, or the square root is negative. So whenever the square root is coming out as negative, that means there will be no solution. So we can just quickly say no solutions. Was there any other way we could have done that? We could have seen that. So we already completed the square for that. We had x minus 2 whole squared plus 3. So we already discussed the scenarios. So basically, this is sort of like this. This is our 2, 3. So the graph is not even touching the x-axis. So it will have no solutions. Let's look at other examples. So this was a very good example of showing both ways of solving quadratic equations. Let's say we have this. Minus 2x squared plus 8x plus 11. And we re-express that as minus 2x minus 2 plus 19. Right, okay. So again, method 1, quadratic formula. So we can try x is equal to minus b plus minus b squared minus 4ac divided by 2a. So minus b is minus 8 plus minus b squared is 64 minus 4ac. So 4 times by minus 2 times by 11. So minus 88, this will become plus 88 divided by 2 times by a. So 2 times by minus 2. So let's simplify this. 64 plus 88, 152 divided by minus 4. So one answer for this would be minus 8 plus root 152 divided by minus 4. The other answer would be minus 8 minus root 152 divided by minus 4. So let's simplify first. So you have minus 8 plus root 152 divided by minus 4. So one answer is this, minus 1.082. If we do the negative sign, you will get 5.082. Now let's try with the completed square method and see whether we get the same thing or not. Completing the square. So we had minus 2 x minus 2 whole squared plus 19 equal to 0. So what we can do now is first take 19 on the other side and divide by 2 on both sides. So you will have minus 2 x minus 2 squared equals to minus 19. Fortunately, minus minus cancels out. Take 2 on the other side also. This would give us 19 over 2. Now, when we take the square root on both sides, one thing we have to remember, we have to take the plus minus sign into account. So this would be equal to plus minus root 19 over 2. So the final answer would look like 2 plus minus root 19 over 2. So either it's 2 plus 19 over 2 root or 2 minus root 19 over 2. So let's calculate that. So 2 plus square root 19 divided by 2. One answer is coming out to be 5.082, same as this one. And if we plug in the minus sign over here, this would be minus 1.082, exactly the same as this one. So it depends on the question, what methodology they are requiring. If they have specified that we have to use the completed square method, then we have to use the completed square method. If they have said quadratic formula, then we have to use quadratic. And if they have left it unspecified, then we have a choice. However, it still depends on question to question. You have to look at what the question is actually asking you to do in the previous parts. Alright, so we will continue this topic in the next video. This concludes the completing the square, discriminant discussion, and solving the quadratic equations. Hopefully in the next video, once we finish this topic, we will look at more past paper questions. See you in the next video. Bye-bye.